This video is going to cover three sections, all dealing with properties of exponents. The first property involves multiplication of the bases, but in this case we're going to add the exponents a plus b. For example, if I have x squared times x to the fifth, that is going to equal x to the 2 plus 5, which is x to the 7th power. Now the reason this is true is because the x squared represents x times x, and we're multiplying it by 5 more x's being multiplied together, and that means altogether there are 7 x's being multiplied. Likewise, when we are dividing, the division turns into subtraction of the exponents. Let's say we have x to the fifth divided by x to the second. We would subtract those exponents and get x to the third. Now what's really happening here is, let's say we have x to the fifth, which represents 5 x's being multiplied together, being divided by 2 x's being multiplied together. If we were to cancel in each of these situations here, we would have 3 x's left over in the numerator, and that would be x cubed. The third property says whenever you have a power being raised again to a power, you multiply exponents. Let's say we have x squared getting cubed. That outer power of 3 says that the x squared is getting multiplied by itself 3 times, and then using property 1 up above, that says add the 2 plus 2 plus 2 to get 6, and you've got x to the 6th, which is basically what you get when you go 2 times 3. In property 4, it turns out that anything to the 0 power is equal to 1. And that basically says if I have 5 to the 0 power, that equals 1. 18 to the 0 power, that equals 1. Anything to the 0 power equals 1. With a couple caveats which we'll explain in a little bit. The fifth property, x to the negative a equals 1 over x to the a, basically says if I have something like 5 to the negative 2nd power, that equals 1 over 5 to the positive 2nd power. We are used to thinking of an exponent as something that tells us how many times to multiply a base by itself. Well, that only works for positive whole numbers. When you have a negative exponent, that actually refers to how many times you divide by 5. In this case, we're dividing by 5 twice. Now, I like to think of this in kind of a strange way. I have an interesting analogy. I like to say that a negative is a ticket that lets you ride an escalator. And you have to use up that ticket to ride the escalator down to the denominator. And in the process, the negative 2 turns into a positive 2. Likewise, if you already have that 5 to the negative 3rd down in the denominator, when it rides the escalator, so to speak, that goes up to the numerator, and you get 5 to the 3rd upstairs over 1. Okay? Now let's talk a little bit about these two properties and why x to the 0 is equal to 1. And I'm not going to give you a proof, but I'm going to give you an illustration. We all know that 2 to the 3rd power is equal to 8. 2 times 2 times 2 is 8. We also know that 2 to the 2nd power is equal to 4. 2 to the 1st power is equal to 2. And if we let this pattern continue, we move on to 2 to the 0 power. Notice how I'm keeping the 2's, the base, the same, and I'm subtracting 1 from each of these exponents, and 2 to the 0 is the next number in the pattern. Well, over on the right side, look at what's happening. The 8 is getting divided by 2 to make 4, divided by 2 to get the 2, divided by 2 again to get 1. So it only makes sense that 2 to the 0 power equals 1. And the next number in the pattern, 2 to the negative 1st, would become 1/2, which is 2 to the positive 1st down below. And finally, 2 to the negative 2nd becomes 1 over 2 squared, which is 1/4. So this illustrates through example what I was showing you up above. And it's not a proof, but it's a nice illustration.